In this problem, we want to give a rank with using the solvent. So where is anthracene most soluble? In which of these? And then what goes next, and so on. So we'll be discussing what is the intermolecular forces in anthracene. Let's write that now. Anthracene. And the solvents are, here you can say, propoxypropane, one name. That's one way of naming an ether, but you can also say dipropyl ether. So two propyl groups. Dipropyl ether. This we know, that's water. And this is an alcohol, and it's got 1, 2, 3 carbon, so that is propanol. Okay, propoxypropane or dipropyl ether. All right, so I want to know in which of these is going to dissolve best. So now, this molecule is highly hydrophilic. So I'm going to do, so it likes lipids. So non-polar solvent. So it's lipo, that word, lipophilic, and is also hydrophobic. Let's see what those names come from. So here, this molecule doesn't only has carbon and hydrogen. So the only force that we have here is Lambda dispersion forces in that anthracene, so which are pretty weak. So in hydrophobic solvents, such as this, for example, where we only have Lambda dispersion forces, we don't have interaction. We say it's more liking this. So this likes more these molecules that are nonpolar. So nonpolar, that's also nonpolar. So that's the concept. So lipophilic means it likes this type of molecule. In hydrophobic, so the word phobia means I hate it. So hates water. So already the words say that. So, but point is that when you have water, as we have said in many examples before, we have the strongest force is hydrogen bonding. And we also have hydrogen bonding in propanol. But propanol has the, say, nonpolar part. And so Na, so nonpolar here. So carbon-carbon. And this part being polar. So we can say has also a balance, if you will, between a hydrophilic portion. So that part would like water because it can do the same type of interaction. So hydrophilic. And this is hydrophobic, this part. But having about the same, say, weight, relative weight, this alcohol is freely soluble in water. This part actually, say, weighs more. So in alcohols, typically with 1 carbon, 2 carbon, so methanol, ethanol, propanol, up to butanol, but these are freely soluble in water. Soluble in water. As you increase the carbon chain, now the hydrophobic portion, the part that is nonpolar, becomes to be is larger and larger. So more of this than there is polar. So there's no compensation here. I don't have as many chances of hydrogen bonding relative to that. Remember, it's always replacing. When you dissolve something in water, you need to be replacing this interaction with something similar. And molecules that have this hydrophobic part large are not given much chances to do this in the network. They do have one, but as this becomes larger and larger, then it is less water soluble. And typically, this is like borderline with 4 carbons. Now, propanol is still 3 carbons, so it should be in a way similar to water, but you have this hydrophobic portion. So we can have some affinity, let's say, with hydrophobic molecules. So bottom line, this being nonpolar, only London dispersion forces will dissolve in something similar to that. And the most similar here is propoxypropane. Here you have this carbon chain, 3 carbons, 3 carbons. So the solubility should be the highest, and I'm going to just put a number here to assign the ranking. So it will be more soluble here, followed by ethanol, propanol. Again, because propanol will have a part of the molecule is hydrophobic, similar to that. And last is water. So it will not dissolve in water at all.